Lesson 10-2, Probability and Counting. When two events A and B occur, the intersection of A and B is the set of all outcomes in the sample space of event A that are also in the sample space of event B. So if you think about a Venn diagram, it's the overlapping parts. So in the picture, the intersection part would be right here, that dark green section. To determine the probability of an outcome from an intersection of two or more events, find the ratio of the number of outcomes in both events to the total number of possible outcomes. The symbol for intersection looks like a lowercase n and is associated with the word and. So we would read this as the probability of event A intersecting with event B, or the probability of A and B. Probability rule for intersections. So again, taking the number of outcomes that are in A and B divided by the total number of outcomes in both out of all of the events. When two events A and B occur, the union of A and B is a set of all outcomes in the sample space of event A combined with all the outcomes in the sample space of event B. So in the Venn diagram, the shaded portion represents the union. So that would be every single piece in there. The symbol for union looks like a U, and it is associated with the word or. So we would read it as the probability of elements in A or in B. And the formula for union, the number of elements in the union of two events A and B is the number of outcomes in both events A and B minus the number of outcomes in their intersection. So you don't want to duplicate them. So it's the event A outcomes plus the event B outcomes minus the ones that are in both. For example, a fair die is rolled once. Let A be the event rolling an odd number and B being the event of rolling a number greater than 3. Find A intersecting with B. So find the probability of A and B. If we think of we do a Venn diagram very quickly. This is A, this is B. A is odd, and B is even. So on a number cube, the odd numbers are 1, 3, and 5, and the even numbers are 2, 4, and 6. So we want to find out if there's any numbers that are in both A and B. Actually, I listed the B rung. The B is a number greater than 3. Number greater than 3. So if B is a number greater than 3, that would be 4 and 5. So I have a 5 here. And let's see. Yep, so those would be our numbers. So the only number that we could have in both would be 5. 5 is a number that's an odd number that's greater than 3. We only have one sample space or one possible outcome for that. Second one, an integer between 1 and 10 is generated by a random number generator. Let A be the event generating an even number. So I'll write that down. A is even, and B is to be the event of generating a number less than 7. So a number less than 7. So the even numbers between 1 and 10 would be 2, 4, 6, 8, and 10. And B, numbers less than 7 would be 1, 2, 3, 4, 5, and 6. So if we look at those numbers here, we want to find the intersection of A and B. So numbers that are in both A and B. So if I look at those, 2 is in both, 4 is in both, and 6's in both. So this would be 2, 4, and 6. Next, a card is selected from a standard deck of cards. What is the probability that the card is a queen and is red? So out of all the cards, there are 52 cards. Now out of the 52 cards, we want to know what is the probability that the card is a queen. There are 4 queens, and out of the 4 queens, 2 of them are red because you got a queen of hearts and a queen of diamonds. So that'd be 2 out of 52, which simplified would give us 1 out of 26. Now you could put that as a percentage, or you can keep it as fraction. If you put it as a percent, this would be like 3.8%. Next, billiard balls are numbered from 1 to 15 and are either striped or solid. A billiard ball is chosen at random to determine who will start the game. What is the probability that the ball will be striped and even? So if we have 15 balls here, out of the 15, what will be the probability that it'll be striped and even? So the bottom 2 rows are striped even numbers. We have 1, 2, and 3. So we have 3 out of 15 reduced would give us 1 out of 5. Next, a fair die is rolled once. Let A be the event of rolling a number less than 5. So A is less than 5. And B is a multiple of 2. Okay, so a fair die is 1 through 6. We got 1, 2, 3, 4, 5, and 6. So it has to be less than 5 for A. So that's 1, 2, 3, 4, and 5. 1, 2, 3, and 4. Multiple of 2. So multiple of 2 would be 2 and 4. So the ones that are, so this one's finding the union of them. So the union would be, I have to list all of them. So 1, 2, 3, and 4. And there's also multiple of 2 is also 6. So I have to include 6 here. Next, a random number generator is used to generate one integer between 3 and 15. Let A be the event of a multiple of 3. So multiple of 3 would be 3, 6, 9, 12, and 15. And B is the event generating a number greater than 11. So greater than 11, so that would be 12, 13, 14, and 15. So now let's find the union. So A union B. So I have to list all of the numbers that I have up here. So that's 3, 6, 9, 12, 13, 14, and 15. That would be my sample space for finding the union of those 2 events. Next, let A be the event of the spinner landing on a blue section, and let B be the event of the spinner landing on a section with a number divisible by 3. What are the possible outcomes for each event? What are the possible outcomes of landing on A? For blue, that's 7 and 15. For B, B is the event of the spinner landing on a section with a number divisible by 3. So I can divide by 3. So that would be 3, 9, and 15. And then A and or A or B. So if I list those, that would be 3, 7, 9, and 15. Next part of our lesson, the complement. Complement of A consists of all the outcomes of sample space that are not included as outcomes of event A. A complement of event A can be noted as A with a tick mark at the top, as shown in the Venn diagram. The probability of rolling a die and getting a 3 is 1 out of 6. The probability of not getting a 3, there are 5 possible outcomes for this event. So 1, 2, 4, 5, and 6. So the probability of not getting a 3 is 5 out of 6. Notice that this probability is also 1 minus the probability of getting a 3. So 1 minus 1/6 is 5/6. So when you think of the complement, think of not getting something. So our formula would just be 1 minus the probability of getting that specific event. So an example, Panju subscribes to a movie streaming service. For movie night, he is going to let the program randomly pick a movie from his list of favorites. What is the probability that a comedy movie will not be chosen? So there are, we have to add up the total number of movies. Let's add those up. So that's 44 plus 109 plus 8 plus 112 plus 13 plus 30 plus 5 plus 29 gives us a total of 350. So out of the 350, I'm going to put 350. So I'm going to use 1 minus the probability of event A. So 350 over 350 is our 1 minus, out of the 350, how many of them were comedy? There were 112 that were comedy. So if I do 350 minus 112, so give us 238 out of 350. And if I try simplifying that, 238 divided by 350, that gives us 17 out of 25 would be our fraction. If you put it as a percent, that would give us 0.68. Or 68%. Next, Leanna picks or packs a fruit basket for her friends. If she randomly distributes each piece of fruit to a friend, what is the probability of someone not receiving a banana? So if you look in the basket, there are 1, 2, 3, 4, 5 pineapples. There are 1, 2, 3, 4, 5 apples. There are 1, 2, 3 pears. And there's 1, 2, 3 bananas. So that's 10 plus 6 is 16. So out of 16, 16 out of 16 minus bananas, there were 3 out of 16. Subtract, will give us 13 out of 16. 13 divided by 16 is times 100. This would be about 81.25%. Or you can keep it as 13/16. The nearest hundredth, what is the probability of someone receiving a banana? So receiving a banana, that's 3 out of 16. 3 divided by 16 gives us 0.1875. The nearest hundredth, that's 2 decimal places. The 7 tells you to round this 8 up. So this would be 0.19. And our last question, the Harvest Fair sold 967 raffle tickets for a chance to win a new TV. Complete the table to find each probability of not winning the TV with the given number of tickets. So if there are 967 tickets, I would have to do 967 minus 20, divide that by 967, and then multiply that by 100. So the nearest percent would give us roughly 98%. It was 200, so 967 minus 200. Divide that by 967. gives us about 79%. You had 100 tickets, 967 divided by 100, or 967 minus 100 divided by 967 gives us roughly 90%. And if you had 1 ticket, this will be 966 divided by 967. You would have roughly 99.9, or you can think of it as 100% chance. Actually, it has to be 99%. So you do have a ticket, you do have a percent, have a slight chance, so we'll put that 99.9%. That is our lesson on probability and counting.